Hi Chem Peeps. Today we're doing final exam review and the topic of today is balancing equations. Now again, I shared in my other videos for final exam review, a teacher has to cover on their test a year's worth of material in a certain time frame for the student. And so not everything can be on there. So what is it that after 31 years I've included on my final exams? That's what I'm going to go over today. So we're going to go through questions 70 through 77 from my exam, covering balanced equations. Now, first thing, my students always had access to the flow chart in first year chem that helps identify the different types of reaction types. So just real quickly, we'll go through the different things that you need to know. There are 5 basic reaction types. There's decomposition, there's synthesis, there's combustion, there's single replacement, and there's double replacement. And my flow chart, which I've covered in videos through the year for balancing and identifying reaction types, you can go back and see that, uses this flow chart to identify reaction types. So basically with synthesis, we're looking at something that produces one product. So you can see here in my generic equation that I have 2 substances coming together to form one thing. That is going to identify my synthesis. In decomposition, it's the exact opposite. I have one thing breaking down into 2 or more things, and that's going to define decomposition. Combustion always produces carbon dioxide and water as the product. So you can see that here in this generic reaction, and that's going to identify combustion. And then we have single replacement and double replacement. Single replacement is going to be a single element plus a compound. And you can see in this example, the cation switch places to form a single element and another compound. We can also have that happen with halogens. So Y minus and X minus represent halogens. They're going to switch places. And so we have an element plus a compound going to an element plus a compound. Now in double replacement, we have 2 compounds, and I always compare this to square dancing, the partner switch. So the 2 cations, the A plus and the B plus, switch places in the compound. So we have compound plus compound goes to compound plus compound. We are going to refer to the activity series when we talk about a couple of the equations I have on here. And the activity series basically tells you for single replacement reactions whether that single element can replace the other ion of the same nature in the compound. For example, in the one that we're going to do, I'll just show that real quickly. The one that's in the problem that we're going to cover is copper and zinc. So if we look here, copper is right here and zinc is right here. Zinc is more reactive. Therefore, zinc will replace copper in a compound if it's in a single replacement reaction. And we'll refer back to that here in a minute. And likewise, if it's the halogens, if we have the second equation down here, you're going to use the halogen series. Fluorine can replace any of the other halogens, and iodine can replace none of them. So this is an increasing value here. Okay, so we're going to make reference to that flow chart. What is going on here? I've got to get this back to its regular size. I kind of messed everything up here. Let me see if I can get everything back. There we go. So we're going to refer to that. Also down here I have my solubility rules. So we're going to look at that when we get to a double replacement reaction, and I'll refer to that. So let's look at the questions that I had on my final exam. So starting with the first question, question 70, it asks, what type of reaction will always produce carbon dioxide and water from burning of oxygen and a hydrocarbon? So we just went over the reactions, and we talked about the different type of reaction types, and that is going to be your combustion reaction. And I need to make this just a little bit bolder. Okay. Next question. Which of the following is a synthesis reaction? We talked about synthesis. It's when 2 things come together to form one product. And the only reaction that has one product is A. So the answer is going to be A in this question. Question 72, what type of reaction uses the activity series to determine if a metal will replace a cation in a compound? And we talked about that at the beginning. That is going to be single replacement. Now, it doesn't always have to be a cation replacing a metal in a compound. It can also be a halogen replacing a halide in a compound. And so that is going to be single replacement. 73, what would be the products of zinc plus copper sulfate? So this is, first of all, you want to identify what type of reaction are we dealing with. This is an element plus a compound. So this is going to be single replacement. So if I go to do this reaction, I'm going to have zinc plus copper sulfate. Now, I always tell my students to put the charges of the substances above them. So zinc forms a +2 charge. Copper in this case paired with the sulfate. So sulfate is this poly here. It's a -2, so this is copper 2. So like replaces like. So zinc wants to replace the copper. And we looked at that activity series, and indeed, zinc is more reactive than copper, so this will happen. And so copper is going to be by itself as a metal, and zinc will pair with the sulfate. And if I look at this, sulfate is still a -2. This one right there. And zinc is a +2, so it's a 1-to-1 relationship here, and copper is going to be by itself over here. And the equation is balanced as written. So the answer to this problem is going to be C. 74. What would be the products if magnesium and oxygen react? So this is a synthesis reaction. We have an element plus an element, and they're going to come to form a compound. Now magnesium is going to pair with oxygen, and we need to look at their charges. Magnesium is a +2 and oxygen is a -2. So we're going to keep the 1-to-1 relationship here, but I do need to balance this. So if I balance this equation, I need a 2 in front of the magnesium, so they get 2 oxygens on the right and 2 on the left, and then I need to put a 2 in front of here, and our answer to this problem is going to be D. All right, 75. What would be the products of lead nitrate plus potassium iodide? So we have PbNO3, 2, and this is aqueous, meaning it dissolves in water, plus potassium iodide, and it's aqueous, and it's in water. And like replaces like. So if I just put the charge, I'm going to change my ink color here. If I put the charges here, the nitrate is a poly with a -1. Takes 2 of them to match the lead, so this is a +2. This is a 1-to-1. If we look this up, this is +1 and -1. And so lead and iodine are going to replace each other, and this only happens if they produce a precipitate or something that is not soluble. And we're going to look at the solubility rules here in a minute. So the potassium wants to pair with the nitrate, and we need to check the charges. This is a +1, oops, +1, and this is a -1, and so that's going to be 1-to-1. And then the lead wants to pair with the iodine, and this is a +2, and this is a -1, so we need to bring a 2 down here. So let's look at those solubility rules. If both of these are aqueous or soluble in water, this reaction doesn't happen because all of these break into ions, and there's no change then. But we need to see if there's a precipitate, something that's insoluble that forms. So we have potassium nitrate, and we have lead iodide. So if we look at the rules, nitrate, whoops, that's not what I want. I don't know why that's doing that. Okay, so nitrate is rule number 1. All nitrates are soluble, so that's going to be aqueous. But we have potassium iodide, and there's no rule on here for iodide, but all the halogens tend to follow the same rule. So we're going to look at 2 because it's about chlorides. All chlorides are soluble, except, and if you look right here, lead chloride is not soluble. Okay, so that means it's going to form a precipitate. It's going to be in solid form, not in aqueous form. So when I go to put my states on here, this one's aqueous because it's soluble, this one's a precipitate. And if I balance this equation, I have 2 iodines on the right and only 1 on the left, so I need a 2 here, and I need a 2 here, which balances the nitrates and potassiums. So it says in question 75, what would the products be? The products are going to be letter A, lead iodide and potassium nitrate. Okay, 76. We need to make some space here for writing. In 76, they're having us balance equations, and I need to determine which set of mole ratios are correct for the balanced equation. So let's go ahead and look at the first one. We have sodium plus water gives us sodium hydroxide and hydrogen gas. Now, when you're balancing equations, the only place that you can put a coefficient or change is a coefficient out in front of each of the substances. This is sodium. So if we look here, we have 1 sodium, 2 hydrogens, and 1 oxygen on the left side. And we have 1 sodium. We have 3 hydrogens, 1 here and 2 here. So 3 hydrogens. And remember, this is just a running total of what's in the equation. So I'm going to start with the hydrogens. I'm going to come here and put a 2 here. And I'm going to tell you why. I'm always going to have an odd number with a single hydrogen in the sodium hydroxide added to an even number over with the hydrogen gas. So if I put a 2 here, that's going to apply to everything in the compound. So that's going to change this to a total of 2 oxygens, and then I'll have 2 hydrogens plus 2 more. That's now 4. So if I go to the right side of the equation, I now need 4 hydrogens. So if I put a 2 here, that applies to both of these. That changes the hydrogens to a total of 4, the oxygens to a total of 2, and then I need a 2 here to change the nitrogen to a 2, and it is now balanced. And so our ratio being these numbers out in front, it's going to be 2, 2 to 1. And so if we look here, that is going to be A as our answer. Let's look at the last example. I've got to make some room. I kind of wrote big here. Oops. Nope. I don't want that. And I'm not sure how I get rid of it. There we go. Okay, so let's go back and erase this work. And so I have potassium chlorate. Oh, nope, going to potassium chloride and oxygen. Now remember, the only place we can make changes is out in front, so I can put here, here, and here. Let's put our totals down. We have 1 potassium, 1 chlorine, and 3 oxygens. 1 potassium, 1 chlorine, and 2 oxygens. So looking at the oxygen situation, I cannot make 2 equal 3 or 3 equal 2, but I can make them both equal 6. To do that, I would need a 3 here, so that changes that to 6. And if I put a 2 here, that changes to 6, but it also affects the potassium and the chlorine. So now I have 2 and 2, so then to balance it, I need a 2 here. And so my ratio is 2 to 2 to 3. The answer is C. So these are the questions that I would have asked on my final exam. I hope this helps. If you like it and it helped you, share it, give me a like, or leave me a comment as to what you liked about it or if you need more. And I wish you the best of luck on your final.